Okay, so hello everyone. I hope you are doing great. So let's come up with a new question. So we have come up with a new question. So it's a hard problem with the late code. So basically, it's a trapping rainwater. So in the question, it is given that you will be given n non-negative integer where they are representing an elevation map where the width of each bar is 1 and you have to compute how much water it can trap after rain. Okay, so let me just show you here. Okay, so we will go one by one and we will see that what this question is saying and that how we can approach it. Okay, so so here it's here it is 0, so there is no way it can trap the water. Here it can trap a water, right? Okay, so it will be your 1 unit of water. Okay, now here it will be able to trap the water. Here it will able to trap the water. This much water it can trap. Okay, so it will be your 1 unit of water. It will be your 2 unit of water. It will be your 1 unit of water. We cannot trap water here. We cannot trap water here. We can only trap water here. Okay, and this is your 1 unit of water. Okay, so basically there is 1, 2, 2 to 4, 5, 6. There is total 6 unit of water. Okay, and you have to just return this value that there is total 6 unit of water that you have to that it can trap. Basically, this particular elevation map can trap. Okay, so this is the question, and you have to basically return this now. Okay, so we'll go one by one, and we will see how. So first one is the brute force approach. Brute force approach. So from questions, so for a particular index, let's say I am at here. Okay, I'm let's say I'm here. This particular index I'm present here. So what is the maximum water this particular index it can hold? So if we will go left, if we will go left, we will see that the maximum unit is 2. Okay, there is no any maximum. Okay, in the right, if we will go, so we will get the 3 as the maximum unit. Okay, so what we will say that the minimum of, because if it is left as 2 and there is a right at 3, so it will only store this much water. So we will, what we will do, we will do minimum of left of I minus comma right of I, whichever will be minimum. Okay, right, minus a of I. Okay, so whatever the left, whatever the right, whichever is minimum minus a of I. Okay, so now if we see that, so 2 is the minimum and the value of AI is 0, so it will only store 2 unit of water. Okay, for example, if I take this one. Okay, if I take this one, so it will store the left is 2, the right is 3, 2 3 is your 2, 2 minus 1 is 1, so it will only store 1 unit of water. Okay, so now we will see that what is that basically the time complexity and how we are doing it. Okay, so if I go with the time complexity and the space complexity. Okay, so for particular n, for particular index, so we are iterating for all the I. For all I am moving left and I am moving right. Okay, I'm moving left, I'm moving right. So in and all, it will be I'm moving this much left, I'm moving this much right. So in and all, I'm moving n unit of iteration. Okay, so n into n. So it will be big of n square. Okay, big of n square. Okay, so it will be big of n square. Okay, so it will be big of n square. Now the space complexity, we are not taking any extra space, we are just taking some booleans variable. It will be big of 1. Okay, so the time complexity we are getting is big of n square and the space complexity we are getting with big of 1. So this one is a brute force approach. Okay, now when you will ask this basically answer to the interview, so interview will ask for some better approach, so how can decrease this time complexity. Okay, so now we will see that how we can do this. Okay, let me just copy the slide. Okay, so now we will go with the better approach. One is the better approach. Okay, so what we are doing for particular ith index, for particular ith index, I'm checking that give me the left max. Okay, give me the left max, and for right I am checking that give me the right max. Okay, this one. What if I pre-process the data? What if I pre-process the data? So what I can say that if I pre-process the data, that I maintain an array, so that will give me the left max for that particular index. So left max prefix I can say, and right max prefix. Okay, so it will be my an array, so that will store my left pointer. Basically it will store the maximum value for this ith index in the left direction. Okay. So for 0 it will be 0, for 1 it will be 1. Okay, for let me just change the color. Okay, so for 1 it will be 1. Now for this particular ender the left max value is 1. For this 2 the left max value is 2. For this one it will be 2, it will be 2, it will be 2. Now here it will be 3, and for rest of one it will be 3, 3, 3, 3. Okay, now the same thing we will maintain it for the basically right max prefix. So we'll go with the right. Okay, we'll see what is the max of right. It is 1. What is the max of this one? It is 2. Now the 2, now it is basically 2. Now here it is 3. Now here till left it will be 3, 3, 3, 3, 3. So I have pre-processed the data, right? I have pre-processed the left max, I have pre-processed the right max. So what I can do, I can just iterate the whole array once again. So what I can do, so for a particular index, what I can say that left, what I will do, minimum of left min, left max, comma, right max minus a of I. Okay, so that will give me the answer. That will just give me the answer, and I will just result plus equals to this one, and I will just return the result. Okay, so this is the way how we can basically reduce the time complexity from big O of n square to big O of n. Now we'll see that what is the time complexity and what is the space complexity. So the time complexity is for creating this left max prefix array will be big O of n, plus for creating right max n, big O of n, and for iterating the array once again for calculating the result. So it will be big O of n. It will be big O of 3n, that is equals to big O of n. That will be equals to big O of n. Okay. Now the space complexity is we are taking two arrays, so big O of n plus big O of n, that is equals to big O of 2n. Okay, so we are taking basically the time we have reduced the time complexity to big O of n and big O of n, but we have increased the space complexity to big O of 2n. Okay, now this is a better approach. So interviewer might again ask you some basically it will say that can you try to decrease this space complexity. We are taking two extra spaces, we are taking big of an extra space. So can you decrease it? So now we will go with the optimal approach. So what optimal approach it can be? Okay, so first I will give you the basically the logic that we will be using, and then I will give the intuitions behind this particular approach. So it is a basically optimal approach. Okay, so what I will do, so basically it's a two pointer approach. Okay, so what I will do, I will maintain two pointer basically. One is the left pointer, that is 0, right pointer that is on the last. Okay, so for example if I say 0, let me just change the color to it will be 0, it will be 1, it will be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so the left will be 0, right will be 11. Okay, now I will maintain two variables. Left max, it will tell me that what is the value that is present in the left max till this L, what is the left max. Okay, so it will be initially 0, and here is a pointer that is right max, that will again 0. It will again tell that from R, from a particular index R, what is the right max to the end. Okay, so so the question that we will, the what we will do, we will check if a a of L, if a of L is less than equals to a of R. Okay, what I am doing, I am checking that if a of L is less than a of R, my L pointer will be here and my R pointer will be here. Okay, what I am doing, my a of L is less than R, then I will check if a of L is greater than equals to left max. If it is greater than equals to left max, what I will do, left max, I will update my left max to assign a new value, that is a of L. Okay, if it is not, it means If it is not, A of L is greater than left max. If A of L is less than, if for example at this particular point A of L is less than left max, it means I got the answer. There is someone, basically I can basically trap the water in that one. Okay, so my resultant will be left max minus A of L. Okay, and then L plus plus this one. Okay, the same thing I will do for else case. What I will do, if A of L is less than A of R, right? Now if A of L is greater than A of R, so what I will do, I will again check if my A of R is greater than right max. If it is greater than right max, okay, if it is greater than right max, it means I have to update my right max to A of R, and I have to update my left max, basic right max to A of R, and then in the else, what I will do, rest plus equals to right max minus A of R, and I will just decrement R. Okay, so this is the basically the logic behind this one. Now I will tell you that how what is the basically intuition behind this. Okay, so I for this particular, let's say for this particular one, okay, for this particular one, this one, okay, for this particular one, I know that for this particular one, I know that in the left I have got a value that is a left max that is greater than this particular one, right? So it means that from the left I can store the water. Okay, from the left I can store the water because my left max is greater than my A of L. It means that I can store water. Now how I made sure that from right there is at least one block which is greater and equals to this two, right? Because if there is an element that is greater than or equals to 2, then only I can store water here, right? If my array is something like this one, this one, this one, and there is nothing. From left I got this, but from right I didn't got it. So I cannot store water here, right? So to get the answer here, how did I made sure that there is at least an element in the right which is greater than equals to this two? That's why I'm storing the value here. Now the the answer the answer behind this is this one. See how I am reaching there. At this particular point, I am reaching from 2. Okay, at this particular point, I am reaching from 2. See, now at this particular point, I know that there is at least an element in the right. There is at least an element in the right that is equals to and that is greater than or equals to 2. That's why I'm able to reach here. From here to here, I reach because there is an element in the right which is greater than and equals to 2. That's why I'm reaching here. Okay. So now when I'm reaching here, I made sure, I know that there is at least one element in the right which is greater than equals to 2. That's why I'm directly calculating the value. I'm just doing that left max minus A of L. Okay. So from 2 to 1, see, if you will see this from if what I'm doing that if A of L is less than A of R, if my A of L, let's say I'm here, let's say if my A of L, here my A of L is less than A of R, A of L is less than A of R, no. So I move from here to here. Okay, so now my R pointer moves here. Okay, now again for to move this one, to move 2 to 1, if A of L is less than equals to A of R, it means I got an element that is greater than or equals to 2. So from here to here, I am only able to move when A of L is less than equals to A of R. A of L is less than equals to A of R. Then only I am able to move here. Okay. So in this way, I have made sure that in the right I have got an element that is greater than equals to 2, and in the left I am already calculating from the left max. Okay. So that is the basically that is the intuition behind this. Now we will see the time complexity and the space complexity. Okay. So the time complexity will be, So the time complexity, it will be, we are iterating through whole array. So it will be big of, and we are maintaining to basically we are just iterating from left to right. So big, it will be big of n and space complex will be big of n. We are not taking any extra space. Okay. So in this way, we can solve this particular problem. Okay. Now we will see that how we can. Now we will see the Java code and how we can do this. Okay. So here. So this is the basically the Java code. Okay. So first, what I'm doing, I'm basically initializing my n, that is the length of the height. Okay. I'm making 4.4 is point, basically four variable. One is the left variable, that is denoting the left, that is right, that is denoting the right, left max, right max, and the answer is 0. So what I'm saying is that while my left is less than equals to right, while my left is less than right, I will move till. Okay, what I'm saying that if my height of left is less than height of right, so if my height of left is less than height of right, if my height of left is less than height of right, then what I will do, I will just update my left max. I will update my basically I will move inside this. Now I will check if my height of left is greater than left max. It means that I got a new element which is greater than left max. So I will just increment. I will just update my left max with that value. If it is not, if I got some element that is less than left max, that is left max, that means that I got the answer and I will update the value of I got the answer and I will just update my answer. So answer will be left max minus height of left, and I will just move my left pointer to +1. Okay. In the same way, in the else condition also, if my height of left is greater than height of right, okay, it means that height of left is greater than height of right. Height of left is greater than height of right. So I will just move this basically right max. Okay, so what I will do, I'm doing, if my height of right is greater than right max, it means I got the element that is greater than right max. So I will just obtain my right max. If it is not, I got the answer, that answer plus equals to right max minus height of right, and I will decrement right minus minus. And in the end, once it reaches when the left and right pointer I crossed, then I will just return the answer. Okay, so in this way, we can solve this particular question. So it was one of the best question. It was one of the hard problem, and it was one of the best question. Hope you guys basically like this video, and please, you guys enjoyed this video. So please do like, share, and subscribe. Take care.